Hi, it's Liz Sneddon. Let's have a look at reflecting on the measures of centre and spread. So let's start with reminding ourselves of the different measures of centre. So our centre, we've got three ways we can measure that: shape, mean, median and mode. And to find our mean, we want to add up all of our data and divide by the sample size. To find the median, we want to look for the number that is in the middle, and the mode is our most common or most frequent number. So in terms of complication and sophistication, the mean is the most sophisticated or complicated measurement, the median second, and the mode the third. So when we prefer to use the most sophisticated measure we have available, but we do have certain conditions that we need to think about. So let's start by thinking about the shapes of our distributions. If we've got a normally distributed shape, so a lovely bell-shaped curve, it's symmetric, all those good things, we will find that the mean, median and mode are all the same. And so in that case, in terms of the measures, we could use any of them. They're all good ways to measure the centre. If, however, our data is, for example, right skewed, the mode is always at the tallest peak. The median is the point where 50% are above and 50% are below. And the mean, you can see that the mean is being pulled towards any outliers or long tails that we have. So the mean is being pulled towards the right when we have right skew data. So in terms of the scenario, the statistic that measures the centre the best is our median. That is the most stable measure. If we have left skewed, it's reversed. So the mode is still the tallest peak, the median is still the point where 50% are above and 50% are below, and the mean is being pulled in the direction of that long tail, which is on the left hand side. So that tells me that again my mean is going to be affected by that long tail. Let's have a look then at measures of spread. We've got three ways to measure the spread: range, interquartile range and standard deviation. So let me just quickly explain what the standard deviation is to give you an idea. Now at school you do not need to know this formula or be able to calculate it for NCA, but we do need to understand a little bit, enough to be able to know that this is a measure of spread. So what the standard deviation does, that takes the mean. So we first of all have to find where the mean is, and you can see I've got a line down the middle there with the mean. Then it takes every single data value and finds the difference between the data value and the mean. So the standard deviation is looking at the spread around the mean. So it's a bit different from our range, for example, which is doing the maximum minus the minimum. Then our interquartile range, which is just doing our upper and lower quartiles, so that's the middle 50% of our data. Our standard deviation is comparing to the mean and looking at how spread out the data values are around that point. So when you look at the formula there, we take each data value, subtract the mean, we take the absolute value of that, square it, and add up all of those values. Then divide by the sample size and take the square root of that. So what it means is if our mean is being affected by outliers, so too will the standard deviation, because the mean itself is in our formula. So if we have skewed data, the standard deviation is not a good one to use. Equally, our range, maximum minus minimum, that's going to be affected if we have any outliers. So in terms of sophistication, the standard deviation is the most sophisticated, then the interquartile range, then the range. So that's the order of preference that we would have. If I've got a normal distribution, all three of them do a good job of giving us an idea of how spread out the data is. And the most sophisticated one would be the standard deviation. However, if I've got skewed data or I've got outliers, the range is going to be affected by that skew or outliers, so it's not a good measure. The standard deviation is also not going to be a good measure because that's using the mean values to measure from. the interquartile range is the only one that is not going to be affected by those outliers or skewness. So let's have a look at an example. If I have these data values here, 1, 2, 3, 4, 5. So I'm just going to draw them very roughly on a plot, on a graph, and you can see there, pretty straight. So let's calculate our centres, mean, median and mode. So mean, add up all the values, 1, 2, 3, 4, 5, divide by how many data values I have, which is 5, and that gives us a mean of 3. Our median is the number in the middle, which is 3. So you can see both the mean and the median are exactly the same for the set of data. We don't happen to have any modes for this. No number occurs more than once. So in this case, the mean would be a good measure of centre, as would the median, but not the mode. And so from those choices, the one we prefer is the most sophisticated one, which is our mean. Let's do the same thing with our spread. So there are 3 ways that we can do our spread of this data set: standard deviation, interquartile range, and range. So to find the standard deviation, I take each data value. So I start with the data value of 1. I subtract the mean from it. Remember, our mean was 3. I take the absolute value of that and square it. And then I sum up by doing that to every single data point that I have. I divide that by how many data points I have, which is 5, and then I take the square root, and so that gives me a standard deviation of 1.414. So that tells me from the mean, from that value of 3, this data is spread out on average by about 1.4. Our interquartile range is our upper quartile minus our lower quartile. So that's 4 take away 2, which will give us 2. And our range is the maximum minus the minimum, which is 5 minus 1, which equals 4. So because my data doesn't have any outliers or skewness, I can say, look, all 3 of these measures of spread are acceptable. I could use any of them. And at level 3, we want to use the most sophisticated, so we will use the standard deviation to refer to the spread of the data here. Let's have a look at a different example. So say I have this data set, 1, 2, 3, 4, 30. So when I come to draw this distribution, we can see we've got our data 1, 2, 3, 4, and then 30 is a long way away from that. So that's definitely an outlier. So let's find our measures of mean, median and mode, and we want to think about, is that outlier at 30, is that going to be included in any of these calculations? So to find the mean, I add up all the numbers, 1, 2, 3, 4, and I add up the 30. Remember, 30 is my outlier. So when I then go to divide that by my sample size, the mean is going to be affected by that outlier. So that's not a good measure of spread, a centre for us. So let's ignore that. Let's have a look at the median. Well, the median is just the number in the middle. It's not affected by that value of 30 at all. It's only the middle position. And so our median is still 3. And we don't have a mode. So in this case, we can't use the mean. We can use the median, but we can't use the mode. So our median is going to be the most appropriate measure to use, because the median is not affected by outliers. It is the most stable measurement when we have outliers or skewness. What about our spread? So our 3 measures of spread: standard deviation, interquartile range, and range. So when we calculate the standard deviation, remember we take each data value, subtract from the mean, take the absolute value and square it. That's including that value of 30, which is an outlier. So when I go to divide that by the sample size of 5 and take the square root, my standard deviation is going to be affected by that outlier, as is the mean. So my interquartile range, 4 minus 2, is not going to be affected by that value. And my range, outlier, take away 1, that is also going to be affected by it. So the standard deviation is affected, the interquartile range is not, and the range is. So that tells me that the interquartile range is the most appropriate statistic to use when we're talking about the spread for this set of data. Thanks very much for watching.